Okay, BYP with the Drake TR-3 in its usual service position, high, and it's broke, and it's broke bad. I hadn't operated on 20 meters much. So since there isn't much going on 40, and there's some DX on 20 in the evenings through the night, I thought I'd hook it up and run it on 20 for a while, give it some exercise, and it was working just fine, making about 180 watts CW, a bit over 300 PEP on sideband. Then all you know what broke loose. The plate meter was pegging 600 milliamps, maybe more, with basically no transmitter drive. Plate and load control didn't do anything that were logical. So something's badly messed up. What I saw early on with this rig is that when this resistor, R53 in V11, the first IF amp, that ground connection shouldn't be there. That goes to the cathode, receiver cathode. If that resistor isn't feeding current from the 150 volt supply to the receiver cathode line, then these two stages here form a multi-vibrator because the cathodes are both on at the same time. These tubes are in parallel and are switched electronically with putting a minus or putting a 150 volt bias on either cathode to turn that tube off. If that cathode voltage goes low, these tubes will oscillate back and forth and slam these finals rail to rail real hard. Huge amounts of current. But that showed up as about a kilohertz burst on the scope. So to troubleshoot this, I turned the RF tune way off, which detunes the mixer and driver so they can't pass any real signal, and the plate current went away. So it's either something really strange coming from drive to the finals, or, well, possibly some kind of parasitic oscillation. And the intended signal is kick-starting some kind of parasitic. Basically, it went from about 180 watts CW on the bird meter to basically nothing, maybe a few tens. So if something's oscillating, it may be oscillating off frequency, or something has happened with the output pi network and it's not right. Maybe a section of a load capacitor opened up. Who knows? It's 60, maybe more years old. That's quite possible. So how to troubleshoot this? First, start it up and check the bias voltages on the finals. They were all good. The cathodes are open and receive, not grounded to allow current to pass. So the voltage there was about 0, 260 on the screens, minus 50 some on the grids, plate 680. So that's all fine, and they're all the same. And transmit it with the gain turned down, just low idling current, nothing changed. Give it some drive, draw a bunch of plate current. The biases on the tubes are all the same. There's not one breaking down. All the cathodes read about 4 volts for about 600 mils. That means about 200 mils a piece for each tube. That's a little bit more than it should be passing. Across 16.5 ohms, about 4 volts would correspond with about 200 mils through the tube, so the tubes are working correctly. As far as bias conditions, all the DC voltages are good. If a tube breaks down or fails, it's probably going to screw up the DC biases. So it's an RF problem. Question, is the output, the RF signals on the final stage, are they correct? Are they fairly clean sine waves and on frequency? I'll put the scope probe probably close to 20 picofarad on a 60 megahertz scope on the grid of the final, which kills the RF down to about 50 volts peak to peak instead of 150 roughly. Pretty much took away all the power on the bird meter. There's an RF signal there. There's a lower plate current. So either there's a parasitic or the scope probe is loading that. And it's B, the scope probe is loading the grid and swamping out the RF voltage because it's changing the tuning on the driver. It does that on every band. That's throwing almost 20 picofarad across a very touchy circuit. So it reduces the drive amplitude to the finals and results what it should be. But what that does is keeps the tubes from drawing a tremendous amount of current. So I then had time to safely look at the waveform on the scope, which was a nice sine wave, and on the counter, exactly on dial frequency. So it's not a parasitic oscillation. At least not that this 60 megahertz and 120 megahertz counter can read. The RF signal on the cathodes were all the same and all looked reasonably correct. For a Class B amplifier, which it is, here's the RF sine wave at the grids. The cathode is a single hump because a Class B is not conducting over half the cycle. So that's what it looked like, and it was of an amplitude that corresponded with the current on the plate meter through the 15, 16 ohms in the cathode. So that's working correctly and not distorted. This pretty much narrows it down to the output circuit. The tubes are working. Oh, they're working real good. Something in the output network has failed. Something on the antenna system is no good. I think I had operated it into an open coax. Could have arced over something. Could have damaged something. But basically, I know the antenna side is good because it's coax to the bird watt meter to my 2 kW dummy load. And no reflected power indicated on the meter. So the antenna jack on out is good. That leaves the output pi network and this little monster right here, the neutralizing capacitor in a neutralizing circuit from the output back through a 2.2 puff, which I didn't replace and I should have. I replaced that 12.5 puff. That's the original air variable. I should have replaced that. But the suspect, since it worked on 40 meters, it would load okay on 40, but 20, it would just draw crazy current. On 15 and 10, it's not making any power. So something is badly wrong in the output network because this rig was making full power on all bands. Observations on the output power versus plate current. The way we check neutralization is to key the transmitter, rotate the plate control with the load control reasonably close to what it should be, and observe whether the maximum power output on the watt meter coincides with minimum plate current with rotation of the plate control. And on 20 meters, it does not. It's way off. So it's very likely that something in the neutralizing circuit has failed. Those air variables are known to come apart. I'm going to replace that 2.2 picofarad, that little monster right up in here, this precision dipped capacitor. I had turned the neutralizing control, see the marks here, they were up here. So I had to turn it from there to get it to start going towards neutralizing on 20 meters. And it is not acceptable to adjust that and go on because something has suddenly failed. And if that capacitor comes apart, as they're apparently known to do, that can lead to bad things. So that's a troubleshooting process to go through this complicated RF circuit step by step. But we do so by making observations of the operation. Firstly, the front panel controls. Noticing that the plate control doesn't properly respond as if it's neutralized. Check the DC voltages first, the DC biases. Check the input waveforms. And again, the scope probe on the grid input really swamped out the voltage, but it was still there, enough to read, and it's proper. And it's responding to increases and decreases in drive. So it has all the earmarks of a failure in a neutralizing circuit. And it has two very critical capacitors that I did not change. So I'm going to summarily replace the 2.2 picofarad just for fun. and possibly even take out the error variable and look at it closely, see if something's failed. But there's an example of how to troubleshoot an amplifier like this. Okay, BYP.